Thank you, everyone. So yeah, as he said, I'm talking about vertical slice architecture tonight and how it compares to clean architecture. Now, what am I actually doing? Well, we're first going to talk about kind of how we got to clean architecture. So when you start out with no idea of how you organize, code or anything like that, what that looks like, and over the years how it's transitioned, and the pains clean architecture solves. Then as a little nugget, we'll just do a quick demo to how you can actually get your hands dirty with clean architecture using one of the templates out there. Then we'll talk about vertical slice architecture. Similar to clean architecture, why is it around? What pain does it solve? What are the benefits there, and why you might use it? And then similar to that clean architecture stuff, we'll go through how you can get up and running really quick with a template that I built. So who am I? I'm Luke Parker. Like we said, I'm from SSW, software engineer there. I love doing open source, so all my stuff I'll put on GitHub, unless begrudgingly, for legal reasons, I can't make it public, it'll be public. I love software architecture, so I'll always be following along anything DD related or VSA, relevant to tonight. And I love going to the gym. Recently though, so I'm not too big. Don't bully me. You can find me on the Twitter on Luke Parker Dev, GitHub on Hona, or lukeparker.dev is my blog, which I recently refreshed. So I, gave myself a little star for that one and a QR code, but I won't be sad if you don't look at it. Cool. So let's kick off. Like I said, what really happens with no architecture? So let's just assume you're building web APIs, since they're fairly common for enterprise apps. You might have a client that calls your API. Inside your server, it might do a number of things. Now, if you're lucky, it might do some presentation logic, that being HTTP communication potentially, or if you're using another thing like protobuf or gRPC, any of that stuff, it'll do something there, right? It has to translate a request to your code. Inside of it, you might do some business logic. So given some data, do I transform some things? Do I give you 10 points because you submitted this thing? Do I, whatever that is there. Then you have system logic. So, now I have decided this business outcome. What do I actually do with it in terms of another system? So the easy example of that is I'm going to write to a database. So in your API, you need to have the code to talk to your database, do your logic, and your presentation logic. Now this diagram is pretty naive. It might not necessarily be ordered in that way, but the big box there is saying, in your API, you might have this stuff. Now, what does that usually look like? We call that one the spaghetti architecture. Everything's intermingled. Every developer will do it differently over, let's even pick a small time frame. Over a month, 2 months, 3 months, whatever, you're going to have a pretty messy code base, and it's going to be a nightmare to deal with. Within a .NET implementation, what might this look like? Following on from one of the .NET new templates, this might look a little bit familiar. You might have a web API project, and within that maybe some folders, a controller or a list of controllers, which is your presentation logic. Maybe a data folder is fairly common, where you might have EF core context or repos or whatever it is, bunch of services which probably just do a whole bunch of stuff and way too much. But who knows? This is just a stab in the dark. With spaghetti architecture, you could even try and do it the right way and have tons of projects, but there's no consistency, so it still ends up being everything all together as spaghetti. Now this you can kind of call a monolith, where it's just a mega app that grows and it's all there, hence kind of the monolith. It's just a big thing all together. What are the benefits, right? For a small app, it could be good. There's little to no abstraction, so you don't have that cognitive load of there's all these patterns applied. You can think back to the old example of everyone jokes about Java developers and their code, where it's like you need your ultra-wide monitor to see the factory constructor, buzzword. With a monolith, no architecture, you probably won't have that, because you are just doing what you need. It is quick to build, so if you're one guy building a hobby app, maybe you don't need architectures, you just do whatever you want, and it probably will be quick to build because you're just going, you're not wasting time. You have the potential for performance, so the keyword here is potential. I guess if you really care about microseconds and stuff like that, abstraction obviously costs CPU cycles, and even cognitive load, but we talked about that, right? Performance potential there. You probably might not want .NET if microseconds matter for you, but with the latest AOT compilation and even the native machine code experiments, maybe there's room for that. But in an enterprise app, the performance thing is not really a concern. But hey, it's a cool thing to kind of remember that if you pick one architecture as the best thing, there are actually benefits to other things. Other architectures, never kind of toss one away and go, oh no, it's crap, because it's spaghetti. There are benefits. The main downside, inertia. I coined it inertia. You can call it whatever you want, slow down, anything like that. As the size of the system increases, so does the dev time in an exponential way, right? Early on, it's really quick. So one guy on a project that lasts a week, you won't get to that point where the inertia is so high it sucks to build. But if you pick 10 devs working on a project for 10 years, 9 years in, you're really at a standstill. Like, you're probably fixing bugs and they take weeks, and your business is like just given up because it's not doing anything, right? So that's the main pain for enterprise apps. And obviously following on from the inertia, because of that, if you have multiple dev teams on one app or one project, one code base, that monolith downside of inertia just really kicks in. The other thing, right, you've got spaghetti, you probably have one common data folder where you just have all your repos or all your EF core or all your scripts, whatever data access you have. You probably have it all in that one way. Any other packages spread throughout, right? So if you want to change a technology, or maybe it's a long-lived project where you have to upgrade if you're trying to keep up to date, all these changes are going to be a big nightmare where it isn't really abstracted or simple to upgrade and test in isolation. It's just deep all throughout the code base, and that's going to suck. And obviously because of that, right, because there is no abstraction and everything's so deep, it's very hard to test, which we'll get into testability a little bit later. So what if we separate some of the technical concerns of the monolith? So bringing back to this little sequence diagram we looked at, not sequence, top-down diagram. What if we instead had the client making a request, and it was very direct in that we have, yes, here is presentation logic. Let's use a web API that does HTTP, JSON responses, fairly straightforward. What if it just does that, communication, serialize, deserialize, and then it goes down from a web thing to C# stuff into a business logic layer, and that business logic layer only does the business logic. So no data access, it just gets to the point of what do I need to do, and then I can tell the data access layer, hey, write this record, delete all these records, whatever you've got to do. It just does that, and obviously eventually it does need to hit some system if you have a database. How would this look like if you did it in a .NET project? Well, to enforce the layers, projects is the standard way. The main upside, a lot of people early on, especially if you haven't been doing it for a long time, you might go, oh, folders are awesome, I'll just do folders. It takes a lot of effort to make projects. They create like 2 folders and an extra CS proj file. The quick reason that you kind of take for granted is if you try and reference, say presentation reference business logic then can't reference presentation. So there's no circular dependencies with projects, but if you have folders, right, you're allowing that spaghetti thing where anything can reference anything. So this is one improvement on the monolith, right? There's not a big amount of differences. You'll notice there's still a controllers folder, there's still a services folder, maybe there's some models, and maybe in the data access there's more models or repositories or an EF core thing. So it's kind of just moving the folders into projects to give you a little bit of intention in where you're organizing things. So this one is called N tier. In this case, we have 3 tiers. We have the more. We have, the data, presentation, and actual app stuff. Same thing with the monolith, slightly less, right? It's not immediately intuitive in that you need no, upskilling, but it's not very complicated. You see, oh yeah, there's data stuff here. Here's where I do my logic, and here's some maybe slim controllers, maybe minimal APIs if you're doing the new .NET stuff. Maybe it's just protobuf, whatever it is. Again, pretty quick to build. Once you build the projects, you're not really like wrangling contracts and multiple systems. It's built there. You can dev pretty quick. In this case, there's a little bit of better testability because you are being distinct in that, hey, my data access is over here. You can test your business logic in that the project is there. But because the business logic still is referencing data access, it depends on the data access. So you can test it, but it still will be a pain because you can't unit test an abstraction or anything like that. It is still concrete. So again, we'll get to that, but it's better than a monolith for sure. Same as the monolith, inertia kicks in for sure. Early on, right, you spit out the 3 projects and you just go ham, but you can still build spaghetti within your 3 layers. So maybe there's a little bit of a delay till it picks up and in taking inordinate amounts of time, but it's still there. For the same reason, right, multiple dev teams, that'll just speed up the curve where you're just starting to slow down. So it's not a great choice if you've got lots of guys on a project or it's going to last a long time. Same thing, technology changes impact the whole system. So back to let's see if I can zoom out with the cursor. There we go. The database and data access is at the bottom. So any change here is still impacted by data access. So that's the main problem. Let me jump back. What if we had some clarity between the business use and technical concerns? Well, what if I flip some stuff around here? So this diagram might look a little bit familiar to anyone if they've seen Clean Architecture. Now I'll just kind of relate it to the diagram before. We had business logic. Imagine application and domain here. In Clean Architecture terms, usually together they're called core. Imagine that as your business logic in this case. And presentation is the same. But you'll notice data access, or as it's referred to in this diagram, infrastructure, has moved from the bottom up to the top, and it instead is kind of putting itself into the application. So your core doesn't actually depend on anything external. And this is really the main benefit of Clean Architecture, where you have that testability. You go from, it really sucks to write tests, to I've got abstractions for anything external to my C# code within my app. I can unit test everything and abstract, everything's a broad term, but most of the stuff and just abstract away whatever this scary infrastructure or data access layer is. So that's pretty cool. Now another way you might see this diagram, I did the top down just for consistency as we saw it grow, but if you see any blog post or article, usually you see Clean Architecture as an onion. So this is Clean Architecture, right? I didn't say it at the start, but moving that infrastructure piece out is the core of Clean Architecture. There's more to it, right? But as a starting point to get why you'd use it initially, you can expand on the concepts later, but that's the main thing. Let's take out this scary external thing that if I didn't have to write data access, if data was stored magically, I wouldn't write it. I only want to write my business logic that does value, that does cool things. So yeah, you'll see, right, these 2 gray ones form up the core. Infrastructure is pointing inwards. So there's nothing going to infrastructure, it goes inwards. Which, I'm banging onto it, but it's very important. And once you kind of get that point, it makes sense, but it takes a bit sometimes. Now, this is actually the Clean Architecture diagram from Uncle Bob. Now, it's from his blog. I don't know when it was dated, a long time ago, we'll say. Maybe as old as our next presenter, I don't know. I'm not taking a jab at him. His talk is, 20 years or something, so, it's in line. But anyway, if you've been doing Clean Architecture without really watching the theory and stuff behind it, you might get stuck on these implementations where it's explicit in saying, hey, have a presentation layer, hey, have an application layer, hey, have a domain layer, hey, have an infrastructure layer, and that's all you got. But that's just one way to interpret it or implement it. Immediately, this central piece, which you might call the domain, where everyone usually just puts their data models, where it's, you go in, your domain, you put in your classes, so let's say a to-do app, you'll put your to-do item, maybe users, whatever, and that'll be your whole domain layer. And in infrastructure, you'll have your EF core stuff, application, will marry them together. So your domain usually is very thin. But actually, what is this, right? So entities or domain, we're kind of relating some terms. He's got it written here as enterprise business rules, rules. So there's what, logic and kind of business value in the domain. That's interesting. Then a layer out here, so use cases, some sort of application layer is application business rules. So this is an interesting thing where a lot of people aren't really aware of that part where, hey, your domain can actually have logic and your application layer can have logic. Now that immediately goes, hey, what is the difference? What is enterprise business rules? What is application business rules? And different people can have different takes on it. But what I've settled on, for the most part, is in your domain, you can follow a sort of DDD style of writing entities in that they have logic on them just in relations to themselves on that entity. You can also have services within a domain layer as long as they only deal with entities, more than one entity, otherwise you'd put it in that entity. But the key point being it's unaware of anything external. So there's no abstraction of something external, there's no interface at all. As long as it's basically pure functions or only dealing with its entities that it knows about, then it's good. A layer up in the application, that's where you start interfacing out external systems. So if you have to orchestrate with that, let's say database, you want to fetch from something and then call some logic, your application layer usually ends up being, it defines the abstraction and then calls some enterprise business rules or domain logic and just kind of mediates those few steps, which is pretty cool to write. And that's kind of why a lot of training, you'll even see Steve Smith or Aldalis, his training, I looked at it the other day, he's got it's like a 3 or 4 day agenda, and 2 of the days are on DDD, and the other day, one of the days is on testing, and it's like clean architecture is a really slim bit because they really do synergize really well, and you get tons of benefits out of that. So yeah, 2 different choices, but theories there. You can actually interpret them in different ways. So clean architecture, it's highly abstracted for larger systems. Resilient to technology changes. If you remember the onion, right, infrastructure's on the external bit. It actually doesn't matter what's in there as long as it resolves the contract of I give you an ID or something and you give me that to-do item. It's fine. Your business logic works. It's very testable because again, your domain layer or use entities, depending on which diagram you're looking at, it's unaware of anything external. So you unit test without even having to use any sort of mocking or substitution or anything. It is just pure in memory. You make a new object and call a function and say, this should be this, or it should have thrown an exception. Very easy to test that domain layer. Application, anything external is an interface. You can mock it, auto mock it, bogus, whatever, really easy. There's no like over the wire, wire mock or trying to mock all of EF core or, there's bad rabbit holes. With CA, you're forced to not go down them, which is pretty sweet. The other key thing is you're not actually influenced by anything external. The other major pitfall, like I kind of alluded to, where you make your domain just your kind of database, where it's just your entities that are your tables. Building a clean architecture app, you don't actually have to represent your domain as how you'd fill it out in a database. You could have again, let's drag in DDD, where you have an aggregate root, which is just, let's say, a collection of many classes. It's not a flat structure, which is very easy to go to columns. Let's say it's a big, we talked about DDD, the conference, not DDD, the domain-driven design. Let's say you represent a whole conference. Maybe you'll have a list of presenters, and they have a list of info, and then you've got a list of talks, and let's say you've got some big data structure, and you've got lots of logic in that. You can have your domain like that, and then in infrastructure, all it has to do is satisfy the contract. If you have an interface that says, save my conference, it might be hell to do that, but you're not influenced by anything external. Now, is it a good idea to shove all your stuff into one entity? Maybe, maybe not. That's another conversation. But if you think of the extreme and then shimmy down a little bit in that, hey, I can actually add some logic. I can add some cool stuff. I can use different data types on my domain entities. I don't just have to use things that I know one-to-one map to SQL Server. You get some pretty cool outcomes. Now, constant velocity is the other main thing with CA. A common complaint I'd hear is just like, there's so much abstraction, it's really slow. Sure, it's slower than just splatting out whatever you want. but you won't fall into the same inertia trap. Yes, the initial time is slow, but you kind of have a flat line. Of course, as a system's complexity grows, it will go up. It's going to get more complex, but it's not as crazy as other apps. So yeah, because of that, it's easier to work on by a few teams. I don't think Clean Architecture on its own is a great choice for lots of teams, which maybe you'd pick something else, but we'll talk about that later. So yeah, higher barrier to entry. There is a lot of theory behind it. Like I said, there's downfalls of just using the layers and doing things. There's also trade-offs. You could say, no, actually, I want my domain to be really slim because I only just want that testability. Or maybe you want lots of logic, complex business area where like you're actually solving a hard problem and you want that to be really clear. You need the theory, and that's kind of a barrier to entry. Because of that, right, it depends on training and a disciplined team to use it well. If they don't know that theory, one guy might be the architect. He might have a big plan, write it down on Confluence or something, and it's all perfect in theory. But you onboard a team and you don't train them, you don't go through what it is, or you just assume they know it. They're going to backtrack any decision you might have made. They might have competing opinions because it is very opinionated, right? Consistency is important, and without training and discipline, you can fall into a spaghetti architecture of just muddied up decisions. So yeah, obviously consistent velocity, but a downside is yes, it is a slower development time as a baseline. Your minimum dev time will be higher than a monolith. So yeah, lots of code to write a simple feature. Again, you'll look at a really simple CRUD app that's just going to write and read some records, and you're like, I have to write so much code, CA sucks, never use CA. Maybe you shouldn't actually be using Clean Architecture if it's a CRUD app. If you are just querying some data and maybe doing different selects, maybe GraphQL, maybe just a monolith, maybe an N-tier. If it is really just, I want some IDs, some very CRUD-based API, like if you're not solving some complex business problem, is CA a good choice? Like lots of code comes at a cost, but it also has benefits, and you have to think about it. Like, is my abstractions and explicit benefits that I gain, am I actually using those benefits? CA comes with testability. Am I writing tests? If you're writing tests, should you be writing tests? Why am I writing tests? Like, am I actually trying to reduce risk? Is the risk great enough where I should spend dev time writing the tests? Like, dev time's expensive. If my system breaks, will it cost more than the cost of writing tests? There's tons of thoughts, and you definitely can't just pick out CA and go, yep, every app is like this. Now, how are we going for time? How long have we been running?
About 20 minutes.
Cool. All right. We'll skip the demo. But who's seen like Jason's template or other templates where you just kind of run a command and you have an app? Hands up. Yeah, okay. Roughly. How about I'll just run the command and show you that it's there, and we won't dive into what's in it, just to keep on track. So I'm going to make a directory without all caps on. We'll call it Brisbane UG, and then we'll cd into it. I can say .NET new, and then what do we say? It is just CA, isn't it? I forget. No, yes, we're doing this. We're using an alternative one. We're using the SSW template. It's a little bit different to Jason's, but the idea is there. Now, if you open up the solution that gets built like this, you can open it up in your favorite editor, whether it's Rider or Visual Studio. I won't start that debate now because I've already talked about Clean Architecture, and that's a heated topic. I don't want to drag too many into one. Let's open it here. There you go. So right out of the box, there's tons of templates out there that will give you those layers, so all the theory. There are some trade-offs in every template, so Jason's template, Steve Smith's template, SSW's template, they all make different trade-offs. So again, quick demo, so I'm not going to go into it. A good thing to do is to write it down. Now, a quick, cool thing that you can look at later is ADRs. If you've ever seen them before, they're pretty cool to write down and kind of keep decisions you've made in your head or as a team in history forever. Let me open it. Basically, they're just markdown files that give you context behind decisions. So say in this template, we're saying, let's use EF core and something, something. Here's some problems, here's considered decisions, here's why we did it. So before I talked about the pain, right, of we make some decisions, other guys like other preferences. If you read through your ADRs and keep them really high value and keep the context of why not, then hopefully your team has some consistency if they read through them and if they're accessible. That's another problem. You might write them, but then no one reads them. That I can't really solve in this presentation. So that was the speed run of CA. Now, vertical slice architecture. To talk about vertical slice architecture, let's bring it back to clean architecture. What happens in a request or use case? So when, again, let's say it's a to-do item. When I do something, what happens? So let's say I want to create a to-do item. I have to talk to the presentation layer, so a web API or a controller. Then I might call a service. This might be our application layer where it is a service that mediates with those abstractions. Then I might deal with the entity, whether it is just newing it up or doing some domain logic. And then I might talk to a database. You might have the same sort of structure for all the CRUD operations. But there's a few common things, right? That looking at the end tier, it would look fairly similar where we have presentation and then these two forming business logic or CA, right? It's the clean architecture layers. And then we talk to infrastructure in every case. So this is very flat, which is why you'd call it, layered. There's tons of different terms and slight variations, but we can call it layered in that it builds up like that. What if I just quickly introduce us to a term, the proximity principle? So any quote, any principle, any guideline isn't use this everywhere, but let's think about this one. So what is it? Code that is changed together should live together. Okay, that's interesting. Now, we won't go into the nuance of it, but this is the bulk of vertical slice architecture. So the code that lives together is, well, that changes together. If I want to change how you create a to-do item, I touch all these layers. And back in the Rider solution or the VS solution, you're going to have to jump around a ton of projects. When you have lots of features, each project you're going to have expanded, and you have to be scrolling for a long time to jump around. What if I kind of flip it a little bit, and rather than grouping it by technical concern, group it by the actual feature? So this is where you'd have VSA. Instead of a layered approach, you're vertically slicing it. So each kind of feature you have includes all the code you need for that whole feature, which is an interesting way to think about it. So we can call these features something like create to do, get to do, update to do, delete to do, if it's a simple CRUD example. Now in a web API, what might this look like, right? You have a client that comes in, it makes a request, and eventually that goes into your vertical slice, and it does everything, and you might hit the same database. You might also go nuts with vertical slices. You could have a whole database per feature, you could have crazy stuff, but let's assume you made some trade-offs and you have one database because you don't want to be in pain. That's the bulk of vertical slices, right? There's little to no abstraction because it's kind of like you've got lots of little mini spaghettis. Like you've got a spaghetti, but it's bounded within here. You've got a container around it. You've got a container of this spaghetti. You've got a container of this spaghetti. And if there's only 4 strands of spaghetti in this folder, I can untangle it or tangle it and not really be too upset. There's no barrier to entry really, right? There is some theory around how you share code and whatnot, which we might dive into in a sec. But because it is kind of drawing in the benefits of the low barrier to entry and quick dev time of what you might see in a monolith, you have those upsides. It's kind of resilient to technology changes. It depends what you do. If your slice, which includes data access, contains only what it needs and no code sharing, you can change technology in one slice at a time and not really impact your system. You can have your system build if you migrate one slice. Like let's say I make my own ORM and I want to test it out on the create thing. If that breaks that feature, it's not going to make anything else not build. It's not going to make anything else break. It'll just break my feature and I know exactly the scope of the risk of what I'm doing. The level of testability, again, because it is letting you build lots of little spaghettis, you could choose to write it in a testable way, but you could also make it hell. So testability kind of is a pro and a con in that if you don't enforce a way of structuring your slices, your actual features, you could be really hard to test. It could be really easy. It's easy to work on by many teams for that same reason of it is boxed. If you make a change within this box, it's not going to break 7 other folders. If you go to a monolith or an N tier and change the data access layer, who knows what you're going to change? You're not going to be sleeping. You're going to get a call in an hour that production's down. You wiped the whole, I don't know, some weird bug, right? You don't have to really worry about that if you're doing purist VSA. Which obviously, yes, sleeping well at night. We want that. Now, a downside, which you can hear theory of VSA and go, yeah, that's cool, but I can't have it completely isolated. When let's say you're making a game, and when I, kill an enemy, so kill an enemy feature, you're going to get experience, but that's the experience feature. Like every app has features or slices that do have to communicate. And that is actually the hard piece of VSA. Like, how do these things communicate? And how do I do that? Do I just let them write to each other's data and have replicas of models? Do I use contracts where I'm, sending out a, notification and it picks it up? That's the hard piece. So that takes a lot of time. It's hard to decide what you have as shared code or feature code. So like I talked about with the data stuff, if you're using EF Core, do you have a separate DB context per feature slice? That kind of sucks. Do I have like migrations per feature slice? Do I have a README or an entire ADR or a SQL script in every, you could go nuts. So there is got to be some, balance point. And again, it's similar to the contracts. You have to really put some thought into it and balance that act of what do I get? How much speed up? How much risk am I inducing? So yeah, that's hard. Each feature can be written in its own way. So like I talked about it, again, each slice is its own spaghetti hell potentially. It could be crazy different between features, and over time, you're going to get a spaghetti app that you've kind of just cut up, and it really is just intermingled. So what might this look like with a template? So coming over here, I will jump out back to my repos folder. This is not zoomed in. There we go. Let's make a new Brisbane user group 2.1. And I'll use a .NET new VSA template and then open it in Explorer. And then because I'm on the early access build, double click doesn't work, so I'll drag and drop to open in the bleeding edge. Let's hope it doesn't just blow up. Sorry?
Sounds like Visual Studio is better.
Do I see any errors? Oh. I should have not spoken while it was loading. Now, the main downside I kind of gave that can be automated is that enforcement of structure within a slice. Now with a template, you can actually have .NET New templates that I alluded to, which gives this whole solution. But there's also .NET New, item templates that can generate you just parts of code. So you can run a command and generate a single feature slice. Now, to save time, I've built this one out just as the example app. So let's say I ran, .NET New feature to do. There's some code sharing here. So in this one, I should probably give it an ADR, but I'll just show you the trade-offs, right? I'm using EF Core as a completely shared code base item. So there's risk there in that it's used among everything. But within a feature, there's actual actions among it. So the to-do item has several actions. There's one entity there, so I'm not replicating the entity. You've got a repository, so I don't want to use EF Core right away. Maybe you do, maybe you don't. But the point is, right, if you build up a .NET New template, maybe you use one that's online, but the .NET New template is actually really easy to use. So within your team, maybe you've got decisions that you've made, ways you want to do it. You can kind of actually just copy out a folder and say, publish this to NuGet, install it to .NET, and then it'll just string replace some text. So say you replace to-do as your template item. You can say, hey, every feature has one entity. They have the actions within the feature, whatever you want to call it, and they're all using fast endpoints, minimal endpoints, whatever decision, and that gets you away from the problem of just anything being anything. Now, that's the quick demo of VSA. Like I said, the really hard stuff is that could be two-way messaging. How do these slices communicate? And that's that could be 8 talks in a row. That's a big topic. But one good way, if you're curious about that, is to look at DDD and how you define aggregate routes and/or microservices. How do they communicate? It's a similar concept. Things are isolated. You have to define bounds, and then you have to define how they communicate. And the theory kind of goes hand in hand between VSA slices, microservices, or even aggregate routes in the DDD land. So, which architecture should I use? Who likes monolith? Hands up. Yes. All right. Who likes N-tier? Hands up. Okay. Who likes clean architecture? Hands up. Yeah. Who likes VSA? Hands up. Believers. My hand's up for all of them. I like them all for different reasons, different use cases. But VSA is kind of growing in the, what do we call it? Microsoft space, I guess. There's lots of hype on Google and stuff, but I mean, hype doesn't mean it's a good choice, but it's a good opportunity to kind of explore it. My decisions usually end up with just actually think about it. I've kind of touched on pros and cons, which most talks just show you how to build it. Think about the pros and cons. What are you actually building? Like, what app are you building? Think about it. Like, how long will it last? How many devs will work on it? Will it be one dev? It'll last a long time, but it's only 3 months of dev time, so I can spaghetti architecture. There's 20 devs now, and I know there's another 20 coming on. Maybe I need microservices. Maybe I need a modular monolith. Like, have a think about that. There's pros and cons to everything. But yes, you should just think about it. There's no, kind of one answer to rule them all. The answer that every consultant loves is it depends. So this talk is just a big consultancy, it depends. So yeah, if you want to learn more about a few of these things, there's SSW rules to clean architecture. So it just shows you a bunch of stuff about CA. Rules to better general architecture and code reviews, so stuff similar to ADRs and whatnot. The clean architecture template that I use, so not JSON's one, the SSW one, which has some DDD flavors dragged in a bit more than other templates. A quick blog showing a bit more about how you use the VSA template of mine that I showed. The actual repo. Modular monolith, this is a cool demo repo of a real-world modular monolith. Now, there's a longer version of this talk which touches on modular monolith, but this is a cut-down one. So if you want to explore how a modular monolith works and/or how it communicates, which is valuable for VSA, definitely take a poke around on this one. And for a bunch of clean architecture resources, just use this link. There's a mega list of different things. Cool. So yeah, we talked about VSA. One sec. We got to do the summary slide, guys. Come on. The history, right? We touched on monolith, how it transformed the N-tier, how you drag that bottom piece on top and get testability, and then how you say, hold on, I'm doing this stuff. Let's just slice it and not make everything be intermingled. And then we have VSA, and obviously templates for both, how you get up and running. So thank you, everyone.
Anyone have any questions for Luke?
Yeah, I was just wondering if there are hybrids between, clean architecture, vertical slice.
Yeah.
Repeat the question for the string.
Yep. So the question is there any hybrids that are kind of a mix of clean architecture and vertical slices? And my immediate answer is kind of. It would be funky for a small app to do that. In the longer version of this talk, I did actually have a slide which kind of shows it, where it's a modular monolith. Now, I won't really dive into it right as one question, but let's imagine you have lots of code bases that are entire, let's say, clean architecture. So the 4 projects, let's say there's lots of groups of them as modules. You could have one module be clean architecture and then decide another module is vertical slice architecture. And that's where you could get a hybrid. Same with microservices, right? If they're an entirely isolated thing, you could do VSA for all of them except one. There's choices there. In a small app or even a large app, I wouldn't suggest multiple architectures solely for the fact of like upskilling and the dev complexity. Like you've got to kind of work for your team. Like, what are their strengths? Everyone's human. Like, humans like patterns. Devs, I'm not sure if we count as human, but we like patterns, right? We like being comfortable. So you can hybrid, but I would be quite hesitant in general. Yeah.
I've got a couple of questions.
Yeah.
First of all, if you're doing VSA and your services interconnect a lot, then you're going to define a lot of contracts and you'll have a graph of spaghettis.
Yeah.
Right?
So the question was, if you're doing VSA and you have services that kind of are everywhere and you're defining some contracts. Yeah, and there's lots of communication. You have, instead of spaghetti code, do you have spaghetti contracts? Is that a question?
Yeah, or spaghetti VSA stacks.
Yeah, yeah. And that's kind of what I was mainly aiming at, I think, in the pros and cons, where the major cons are you really have to think about what contracts you have. Maybe you make a wide slice where it does a few things. Maybe you have a narrow one. So I think it is easy to have all common code where you just don't do anything in your slices and you have these common services that are spaghetti. And yes, in that case, you're right, where kind of you're not using it for its, to gain its pros, but without putting a lot of work into planning it and thinking about it 100%. Yeah. Yeah, well, you're moving spaghetti from your end tier normal, your actual code to just this abstraction, which you could argue is worse, where your abstraction is spaghetti. So now you've got to figure out what your abstractions actually do.
Yeah. Referred to as lasagna code.
Yeah. Yes.
Yeah, so my second
Yep.
question is that autocomplete thing in,
Yep.
Is that like the modern feature of Oh My Gosh, or is that something else?
So the question was, is the autocomplete in Oh My Posh, is that a feature of it? Honestly, I don't know. So you mean when I'm typing this and I see
that gray text,
yeah.
on
It's got to be Oh My Posh because, well, it's its own like exe running, right? So it's pretty cool. You just kind of do a dry run through and then I haven't used it heaps. I'm a GUI lover. I love GUIs. Don't crucify me. But if you do a dry run through, it like keeps the history somewhat aware. Like if you override and if I run a different .NET command, it'll probably suggest something else.
No, I know that. So
Yeah, oh, okay.
So it just stores that, but like
Yeah.
This autocomplete feature.
Yeah.
So,
Yeah.
I don't have it in my installation.
You'll know better.
What button did you press to actually make it go all the way?
I press the right arrow. Yeah, so it's grayed out and then right arrow.
Sorry, I've been trying.
Because yeah, the tab will obviously do the file thing.
As much as this tool is cool and all, we've got another talk to come
Yeah,
up as well. So let's try and keep the questions on topic, please.
Cool.
In the clean architecture diagram,
Yeah.
it shows like application infrastructure layer kind of like shows separately, but in
Yeah.
reality you have to relate them, right? Otherwise, how would you do dependency injection?
Yeah, so the question is, application infrastructure are separate here, and application doesn't reference infrastructure. How are they working? If like how do you do dependency injection? How are they wired up? So, application, this inwards layer, has interfaces. So it might be a repository is the easy example. Let's say in application you have to-do repository. In infrastructure, it references application. So you have your concrete class in infrastructure, your interface in application. And then in presentation, this is actually a small little trade-off that every app makes, which is kind of unclear. There should, in theory, be like one circle around these both that wires up presentation infrastructure, but the web API project usually is the presentation layer, and that's got the out-of-the-box dependency injection container usually. So presentation references both application and infrastructure, and that's where it gets wired up. So the concrete class is eventually used by application, but it isn't aware of it. It doesn't reference it. It's because of the inversion of control, right? It is inverted. So yeah.